Okay, so for question B, you have to show that if the conjugate of z is equals to negative z, so this is a sentence, it's not an operation showing left hand side to right hand side. We say that if your situation is this, then you have to show that z is only the complex number with imaginary part only. So sekiranya complex number saya, it can fulfill this equation, then this complex number is only have imaginary part. So this is a showing on a sentence, on a mathematic arguments like that, if then. So we have to fulfill the first situation first for B. For B, if z is equal to a plus bi, means that when you have conjugate of the z equals to negative z, what happens? Conjugate of the z, it will be a minus bi. A minus bi. And then negative z, I write it clearly like that. Okay. So first, left hand side, our conjugate of z will be a minus bi. So if negative z, it will be negative a, negative bi. So in order to make them equal, they say the situation is said if this conjugate equals to this negative z, in order to make them equal, okay, in order to show that this conjugate equals to negative complex number, okay, you can see in order to make them equal, now you can see this is definitely not equal. Conjugate z is a minus bi, negative z is negative a minus bi. In order to make them equal means that your z here do not have any real part, because if the z complex number it have real part, it cannot equal. So in order to show that conjugate of the complex number equals to negative, means the left hand side must be equal to right hand side. Therefore, the real part of the complex number a must be equal to 0. If we come out a value here, definitely they will not be equal. They will not same. Left hand side equal to right hand side. So when the real part a equals to 0, now we're going to prove that then our z is only having imaginary part only, which this situation only can fulfill the conjugate of z equals to negative of z. So this is having 3 marks. So how is it? So the first one, we working out the left hand side, right hand side. So to show that their relationship, left hand side equals to right hand side, our real part must be equals to 0. Then now we can prove that the complex number only have imaginary part. So that will be our 3 marks. Okay, so for question C, they ask you to find back what is their a+b if their complex number fulfill this equation. So first of all, we see, can we move the things to left hand side, right hand side or not? We have complex number a+b we want to find here. Here also got a+b we want to find here, so we cannot move. We cannot move like k value. So therefore, we only can substitute inside our z, which will equals to a plus bi times 2 minus I equals to another side. Another side is a conjugate. Conjugate is a minus bi plus 1, then 1 plus I. So from here, we have to do the comparison between real part and imaginary part in order to solve our a+b. So from here, we expand first. This is what we get, 2a minus ai, and then plus 2bi, then minus bi squared. Okay, so that we finish expand. So how about this? This is how to expand. Okay, a expand to the back, we get a plus ai. Then second item, negative bi minus bi square. Okay, second item, expand to the back. And then come to third item, 1. Okay, 1, expand to the back here, 1. So 1 times 1 plus I will become 1 plus I. Simplify our equation. We notice that got something we can simplify where they are same. We have the same things here. Okay, so this is your real part. This is your I square become negative 1. So negative negative become positive, positive b. So our real part is 2a plus b. Nothing we can do here. So that will be our real part. So imaginary part will be negative a plus 2b equals to I. Okay, so that will be our left hand side complex number, where real part is this, imaginary part is this. So how about the complex number here, when after we simplify? So this is I squared, negative 1. So negative 1, this will become positive, positive b. So the real part will be a plus b plus 1. So this is our real number, real number, real number. Without I means that is our real part. Imaginary part, you can notice here, imaginary part is ai, negative bi, and then I. So how many I here? It will be a minus b plus 1. That's our imaginary part. So after we equal them both sides, we'll notice that because this complex number here equal to that complex number at the right hand side, so they are equivalent. When they are equivalent means that we can compare our real part. When we compare our real part, 2a plus b should be equals to a plus b plus 1. This is our real part. And then compare our imaginary part, negative a plus 2b equals to a minus b plus 1. So we solve this simultaneous equation. Okay, so b plus b simplify, a move to the left hand side, you get a equals to 1. Okay, done. Done with a equals to 1. So we can substitute here when a equals to 1, so negative 1 plus 2b. So what is our b? 3b equals to 3. So your b is equals to 1. So they said find the value of ab. So therefore conclusion, a equals to 1. And b equals to 1. That will be our conclusion as the question asks us to find. So this question is allocate for you 5 marks. So 5 marks dia di mana? First kita nak tengok cara kembang awak. So bila dah kembang, dah pandai kembang, then you can see, do you manage to compare the real part and get the answer? Another one, do you manage to compare the imaginary part and substitute the value at the value a that you finding here to get your b. So this is how we get our 5 marks.